Okay, I'm going to start with number 1 here on test review number 11 worksheet. It asks us to sketch the graph of this rational function. So I always like to go through and gather all the information I can. Now, before I do that on this one, I do want to point out this factor right here of 3 minus x. And as I look at this factor of 3 minus x, if you reverse that, you think of this as negative x plus 3. And when we look at those factors, we don't want to have that negative out front. And so what I would encourage you to do when you have a factor that is reversed like that is I would encourage you to factor a negative out. And so what I'm going to do is I'm going to factor a negative 1 out of this. I'm going to put the negative 1 out front then as a negative. And then this factor is going to reverse, or is going to become the opposite. And I'm going to think of it as the factor x minus 3. Okay? And in fact, I think I'm going to erase that and write it a little bit better for you. And that it is x minus 3 with the negative out front. Now, I generally like to look at zeros. If you recall, zeros are found by setting the numerator equal to 0, and vertical asymptotes found by setting the denominator equal to 0. Before we do that, I do also want to point out that we do have one factor in common here. And if you look, both numerator and denominator have a factor of x. And remember, when there's a factor in common, it is neither a whole nor a vertical, it is neither a zero nor a vertical asymptote, it is a whole. And so I want to point out there that we have a whole where that factor is, and so the factor is x, so that means we have a whole at x equals 0. Next, I will look at my zeros. Remember, I find zeros by putting my numerators equal to 0. And so when I look at my numerators here, we have the x minus 3. And so when I set that equal to 0, I'll have a 0 at x equals 3. We have an x plus 1, which when I solve would be x equal to negative 1. And then we also have an x squared plus 2. But if you set x squared plus 2 equal to 0, it would give you the square root of a negative or an imaginary. So that factor will not be relevant. Now, one other thing we do need to point out, notice when we found that last 0 of negative 1, it had a power of 2. And so that is important with a 0 because when a 0 has a power of 2, or in other words, an even power, remember that at that 0 we will just touch instead of crossing. So I'm just writing out here that we have an even power on the negative 1. Next thing I want to find are my vertical asymptotes. If you recall, vertical asymptotes, denominator equal to 0. Hopefully you guys can see this if I write it in right here. So we're going to have vertical asymptotes at x equals, well, we've already taken care of the whole at x equals 0. Set x minus 5 equals 0, we have x equals 5. Set x plus 3 equal to 0, and we have x equal negative 3. X squared plus 1 can't equal 0. It would be square root of a negative again. And we have x minus 2, which would result in an x equals 2. Again, I want to point out that one of these had an even power. So x plus 3 to the second. So right there, because that, actually I'll just use that right there, because that negative 3 had an even power for a vertical asymptote, remember that means there'll just be no sign change. Okay. Other pieces to point out. You can pretty much assume, but there will be a horizontal asymptote at y equals 0. And that is because on top we would have 1, 2, 3, 4, 5, x to the 6th on top. And in the denominator, 1, 2, 3, 4, 5, 6, 7, x to the 7th. And anytime the larger power is on bottom, remember there is a horizontal asymptote at y equals 0. And then the other piece of information I should probably point out is that, please remember, we have to look at, is this fraction a negative or positive fraction? Well, right here, because we had this negative out front, this means that it is a negative fraction. And when it's a negative fraction, remember when we start at the right, we will start below the x-axis at the right. Okay, so I think that's all the information I have for you. I think I'm ready to set up my graph. So let me attempt to set up a rather crooked x-axis and a y-axis here. As I start to put in information, I know that there's going to need to be a hole at x equals 0, which as I'm looking at my answer key, I'm not sure I actually have that on the answer key. We're going to have asymptotes at 5, -3, and 2. So I set a vertical asymptote at 5, which I'm putting in right now. A vertical asymptote at -3. And a vertical asymptote at 2. Okay. I have zeros at 3 and at -1. And let's see, I got the hole we'll have to remember to just deal with right now. We can't really do a whole lot about it. I mean, I could write maybe an H in there for a hole. We'll have to remember with our even powers to check on those. I think that's about all I can go ahead and put in. So, when we start our graph over here at the right, remember because we had a negative sign out front, we're going to start on the negative side of the x-axis. So we're going to start below the x-axis. As we move towards the left, we will approach a vertical asymptote at 5. And so we will run along that vertical asymptote and head down to -infinity. Now, the vertical asymptote of 5 just had a regular power of 1 or an odd power. So that means I am going to switch signs. And now when I'm on the other side of the vertical asymptote, I will be positive. As we look at here, we have a 0 at 3. So that means we have to either cross or touch through the x-axis at 3. If you go back up top, 3 was just a regular 0, so we're going to cross through the 0 at 3, which means we'll cross through, and then we'll run down and along the vertical asymptote at 2. Okay, as we hop over the vertical asymptote at 2, it was a regular odd power of 1. So we are going to jump back up to the positive side. And as I jump back up to the positive side, between 2 and my next vertical asymptote, -3, notice I have a 0 at 1. So I either need to touch or cross through at -1. If you look back up here, -1 was my 0 with an even power. And when it's an even power, remember it just touches the 0 and goes back the direction it came from. So that means in this case, it's going to be a parabola type shape because we're going to go over, we're going to cross, or we're going to touch at -1 and go back up along that vertical asymptote of -3. And then We're going to hop over the asymptote at -3. Notice the vertical asymptote at -3 had my other even power. So that means I'm going to not change signs. I'm going to stay positive. And then to finish this off, I'm going to run out alongside my horizontal asymptote of y = 0. Hopefully that gives you guys an idea of how to do number 1. I'm going to go ahead and continue this video so I don't have a ton of videos. And so I'm going to change screens. We're going to go to problem 2. Problem 2 is asking us to graph y = cosine x from the interval -2 pi to +2 pi, and then also graph y = secant x. So let's start with y = cosine x and get that graphed. Let me first draw my x and y axis here. I know we often only draw the just 0 to 2 pi, but do notice the range specifically the domain specifically asks for -2 pi to +2 pi. So you want to be able to go out 2 pi in both directions. I'm going to go ahead and label that. If you recall how I like to do this, I like to label all the way out to 2 pi. In the middle of 0 and 2 pi is 1 pi. And then the halfway points of that is pi over 2 and 3 pi over 2. I need to do the same thing over my negatives. I'm going to go all the way out and make it -2 pi. In the middle is -pi. If I do those halfway points, -pi over 2 and -3 pi over 2. In terms of range, remember your cosine graph goes as high as 1 and as low as -1. Now, for cosine, if you recall, I'll worry about the 0 to 2 pi and then I'll reverse it. For cosine, we start up here at a height of 1. We cross down at the first marking at 1/4 of the way, so through pi over 2. Then we're going to come over here, and we're going to have a minimum below pi. Notice that I'm trying to keep that approximately over from -1. Then we're going to come back up. Whoops, cut through 3 pi over 2. I'm getting slightly off there. And then we're going to end with a maximum above 2 pi. We basically want to reflect it over to the other way. So as I go backwards from 0, I'm going to aim to cross through -pi over 2. I'm going to have a minimum under -pi, and that minimum should be over from -1. Cross through -3 pi over 2. And I have a max above -2 pi. That right there in that bluish purple color is my cosine graph. Now, if you'll notice, it also asks me to graph secant. Now, secant, if you recall, they purposely have put cosine and secant together because cosine and secant are the reciprocals of each other. Okay, just as sine and cosecant are reciprocals of each other. If you recall, when we have our reciprocals here, anytime there is a 0, it becomes a vertical asymptote. So, as we go to set this up, since cosine has a 0 at pi over 2, this will become a vertical asymptote, as will at 3 pi over 2, at -pi over 2, and at -3 pi over 2. All of those are vertical asymptotes there. And then if you recall also, we will reverse the graphs. Numbers that are close to the x-axis will be far away from the x-axis. Those numbers farthest from the x-axis will stay in that area. And so basically we're flipping our parabolas, so to speak. So like here, where I have this max at 1, this will be a parabola going up. Notice I actually have it touching at 1 there. So it actually touches the cosine graph. Over here at pi, we have a minimum at -1. We're going to reverse our parabola there. And again, notice they're touching. And then we have the same thing over here at -pi. And that our graph is reversed. Okay. I would encourage you for the test to be comfortable with the cosine secant pairing that we just did, and also the sine cosecant pairing, which would be knowing your sine graph and then being able to create the cosecant graph. Moving on to number 3. As I look at number 3, it asks us if the graph of f of x equals x squared, then use that graph to graph g of x, and g of x is defined as f of x plus 3 plus 2. So, best thing you need to do here is you need to figure out what exactly is g of x. Okay? So as we look at this, g of x is defined as f of x plus 3 and then plus 2. So f of x plus 3 means as we look at f of x, every place I see an x, I'm going to replace it with x plus 3. So this is x raised to the power of 2. Instead of x raised to the power of 2, we're going to say x plus 3 raised to the power of 2. And then we also had a plus 2. So we're going to say plus 2. So that right there is the graph that we need to graph. G of x equals x plus 3 quantity squared plus 2. So basically, you are graphing a translation of the x squared graph. Okay, so you know what x squared looks like. And then if we recall our transformations, the plus 3 that is in the parentheses is a horizontal translation opposite the sign, and so that is going to tell me to move my parabola left 3. The plus 2 at the end is a vertical translation up or down the direction of the sign, so plus 2 is going to tell me to move my graph up 2. So again, let me draw a set of xy axes. I'm going to draw a rather low x-axis because it's just a parabola. It's going to move left and up, so I don't really need anything below the x-axis. There's my x-axis. There's my y-axis. 1, 2, 3, 4 to the right. And when I move left, I need to go at minimum 5 marks. And then normally I would say at least up 4, so I'm going to go at least up 6. 1, 2, 3, 4, 5, 6. If it is helpful to you, you might start by putting in just your basic y equals x squared graph. And if you remember the basic y equals x squared graph, it goes through the points 0, 0, 1, 1, and 2, 4. Thus, also negative 1, 1, and negative 2, 4. So that right there would be your basic y equals x squared graph. I do hope you guys can see this orange. It's a very light color. Hopefully it is visible. Now, where are we taking this parabola? We need to move it left 3 and up 2. If you recall how I like doing this, I like just taking my vertex that was at 0, 0, moving it left 3 and up 2. From there, I like to make my new vertex. And from that point, a parabola goes over 1, up 1, and over 2, up 4. So approximately right there. And then you have to do the same thing on the left side. Left 1, up 1, and left 2, up 4. Here in blue is my final parabola that I should have graphed. Sorry, my vertex ended up a little pointier than it should, but you get the idea there. Okay, this recording's just over 20 minutes. You've got the top row of your answer key, so I'm going to stop here, and then I will start a new recording.